Today, I will show you of how coal-fired thermal power station works. Coal-fired power stations are used to generate electricity. They are the most common type of power station in the largest global megawatt contributor of all power station types. This type of power plants has found widespread application due to its tried and tested design, as well as the cheap availability of coal. Unfortunately, coal-fired power plants, particularly older plants, are not environmentally friendly compared to other types of power generation plants. Coal-fired power plants are non-renewable, not green types of plant. How coal-fired thermal power station work? There are the main coal-fired power plant system: the coal, the exhaust, the steam, the water, the kinetic energy, and the electrical energy. The coal system. As you can see, the coal is delivered via road, rail, or ship and deposited it in a coal yard. And then, stacker reclaimers are used to gather coal and deposit it into hoopers. Then, the hoopers then feed flatbed conveyors. Then, conveyors transport the coal from the coal yard to die silos within the main power station building. One day silo may contain enough coal for one boiler at 12 hours of full load operation. The day silos ensure that any disruption to the supply chain from the coal yard to die silos will not cause a disruption to the boiler and consequently power generation. Day silos feed the boiler directly or by passing the coal through a coal pulverizer. The coal pulverizer are used to pulverize pieces of coal into fine particles. Once unloaded, the coal is then pulverized into a fine powder by a large grinder. This ensures nearly complete burning of the coal in order to maximize the heat given off and to minimize pollutants. The steam system. After that, the pulverized coal is then input to a boiler. Boiler, also called steam generator apparatus, designed to convert a liquid to vapor. Where combustion occurs and coal provides heat to the power plant, this heat is transferred to pipes containing high-pressured water which boils to steam. The common types of boiler fuels: the coal, the fuel oil, and natural gas. The water system. As you can see, the water is transferred to a diuretor. A diuretor are mechanical devices that remove dissolved gases from boiler feed water. The purpose of a diuretor is to reduce dissolved gases, particularly oxygen, to a low level and improve a plant's thermal efficiency by raising the water temperature. And then it transferred it to a boiler feed water pump. Boiler feed water pump pressure is greater than 200 bar or approximately 3000 psi. The work of a boiler feed pump is to discharge the condensate boiler feed water from the hot well to the boiler drum. The economizer. Economizer are heat exchange devices that heat fluids, usually water. The common application of economizer in steam power plants is to capture the waste heat from boiler stack gases and transfer it to the boiler feed water. Types of steam: the wet, dry, and superheated. The steam is a colorless and odorless. This is the wet steam. steam drum. The steam drum is a reservoir of water at the top end of the water tube. The water is heated. This stage, the steam is superheated. Kinetic energy. High pressure turbine is the first main engine turbine to receive steam from the main steam system. This process was chemical energy to heat and convert it to kinetic energy. Then the reheater. Reheated steam will again absorb the heat energy from the boiler to be used in the next level steam turbine. An intermediate pressure turbine receives steam or gas from the high pressure turbine. This is the turbine runner rotor. At low pressure turbine, exhaust energy is recovered while minimizing back pressure. Then the condenser. The condenser condenses the exhaust steam from the turbine for use in the cycle and to maximize turbine efficiency. And cooling tower cools the warm water discharge from the condenser and feed the cold water back to the condenser. This is the natural draft cooling tower. And air preheater. This air preheater recovers the heat from the boiler flue gas, which increases the thermal efficiency of the boiler by reducing the useful heat lost in the flue gas. And secondary air fan. Air fan allows to complete combustion of the fuel inside the furnace. And primary air fan. Primary air fan are high pressure fan used to supply the air for the transportation of cold directly from the pulverizer to the furnace. Exhaust system. Measuring exhaust gases. High oxygen levels, too much air providing during combustion. High carbon monoxide levels, incomplete combustion. This is the exhaust gas system. Electrostatic precipitator. An electrostatic precipitator or ESP remove a certain impurities from air or other gases in smokestacks. Induced draft fan. These fans handle hot flow gas. They are generally more responsive to erosion and corrosion, even with particulate removal equipment. And flue gas desulfurization or FGD removes sulfur from the flow gas after the combustion process to meet environmental requirements. To reduce costs, sell ash from ESP and sell gypsum from FGD. Thermal power station sales. Heat is to airport and hospital. Gypsum and ash to cement factory. Electricity is for mass market. Stack. Stack used by power plant to exhaust combustion gases into the air. Electrical energy. Generator. Turbine generator is mounted on a rotor shaft to convert the thermal energy of the steam from the steam generator to electrical energy. First law of thermodynamics. Conservation of energy. Energy can only be transferred, it cannot be generated or destroyed. Transformer. Transformer help improve safety and efficiency of power system by raising and lowering voltage level as and when needed. And the switchyard. Switchyard controls the electrical energy. It can be considered as the heart of the power plant. This process was chemical energy to heat and to kinetic energy and convert to electrical energy. Example of solved problems in steam power cycle. A steam power plant uses steam at boiler pressure of 150 bar and temperature of 550 degrees Celsius with reheat at 40 bar and 550 degrees Celsius at condenser pressure of 0.1 bar. Find the quality of steam at turbine exhaust, cycle efficiency, in the steam rate. The given data: P1 is equals to 150 bar, P2 is equals to 40 bar, P3 is equals to 0.1 bar, and T1 is equals to 550 degrees Celsius, and T3 is equals to 550 degrees Celsius. To find the quality of steam at turbine exhaust, the cycle efficiency, and the steam rate. The solution: the quality of steam at turbine exhaust. From the properties of steam from steam tables. At 150 bar and 550 degrees Celsius, each one is equals to 3445.2 kJ per kilogram. At 40 bar and 550 degrees Celsius, each one is equals to 6.5125 kJ per kilogram Kelvin. H3 is equals to 3558.9 kJ per kilogram. S3 is equals to 7.2295 kJ per kilogram Kelvin. At 40 bar, Tsat is equals to 250.3 degrees Celsius or 523.3 Kelvin. HF is equals to 1087.4 kJ per kilogram, and HFG is equals to 1712.9 kJ per kilogram. SF is equals to 2.797 kJ per kilogram Kelvin, and SFG is equals to 3.272 kJ per kilogram Kelvin at 0.1 bar. HF is equals to 191.8 kJ per kilogram. HFG is equals to 2392.9 kJ per kilogram. SF is equals to 0.649 kJ per kilogram Kelvin, and SFG is equals to 7.502 kJ per kilogram Kelvin. From process 1 to 2 is isentropic. S1 is equals to 6.5125 kJ per kilogram Kelvin, and S2 is equals to Sg at 40 bar. Therefore, exit of HP turbine is superheat. Tsat is equals to 332 degrees Celsius. H2 is equals to 3047.18 kJ per kilogram. S3 is equals to Sg at 0.1 bar. Steam is at wet condition. S4 is equals to S3 is equals to 7.2295 kJ per kilogram Kelvin. And then the solution for S4 is equals to SF4 plus X4 times SFG4. And then we evaluate 7.2295 equals to 0.649 plus X4 times 7.502 is equals to X4 is equals to 0.877. And then for the H4, HF4 plus X4 times HFG4. Then we evaluate 191.8 plus 0.877 times 2392.9. And then the result for H4 is equals to 2290.37 kJ per kilogram Kelvin. And then for the cycle efficiency, the solution, D is equals to H1 minus H2 plus H3 minus H4 over H1 minus HF4 plus H3 minus H2. And then we evaluate 3445.2 minus 3047.15 plus 3558.9 minus 2290.37 over 3445.2 minus 191.8 plus 3558.9 minus 3047.18 is equals 0.4426 times 100, and then the cycle efficiency is 44.26%. And then for the steam rate, the solution, 3,600 over H1 minus H2 plus H3 minus H4. And then we evaluate 3,600 over 3445.2 minus 3047.15 plus 3558.9 minus 2290.37. And then the result is 2.16 kilojoule per kilowatt hour.